Thanks, Ben. Hello, everyone. My name is Erander. I'm a solution architect at Esri UK, and together with my colleague David, we're going to be talking about developing applications to meet specific needs. That is to say, bringing ArcGIS capabilities into your custom or bespoke applications. There are a wide range of tools and options available to customize ArcGIS. These include low and no-code builders, which you may already be familiar with, such as story maps, dashboards, instant apps, and experience builder. And these allow you to customize the experiences that your users have, being able to take advantage of some of the capabilities from ArcGIS, but with the complete advantage of not having to write any code. However, these may not always meet your needs or your specific workflows. This is where ArcGIS developers come in, giving you the ability to extend and customize ArcGIS and bring its capabilities into new apps or geo-enable existing ones. It gives you the ability to sculpt and center ArcGIS around your users. At the core of ArcGIS developers are three key concepts: the developer experience, location services, and a consumption-based business model for those applications that don't directly use ArcGIS Online or ArcGIS Enterprise. So we're now going to take a look at how you can get started with the ArcGIS developer options available. Everything starts with a world-class developer experience. The ArcGIS developers website gives you easy access to everything you need, including guides, API references, sample code, and ArcGIS content. Key to this is the dashboard, which is tailored to you. An important part of the dashboard is giving developers the means to easily access ArcGIS content and services through a model that meets their needs, either through an API key or using OAuth authentication, and start building apps straight away. Let's take a look at the important differences between these methods now so you can understand what the differences are and what's most appropriate for you, so you too can also start building applications quickly. Firstly, let's look at API keys. API keys are used for your application to be able to access ArcGIS content and location services, such as maps, geocoding, base maps, as well as premium content. API keys are most appropriate for when you need to secure your content, but your app can anonymously use ArcGIS services. That is to say, the ArcGIS services being used will trust your application, but will not care who in your application is using it. API keys are generated on the ArcGIS developers website. You can generate multiple API keys depending on your needs. The developer dashboard also comes equipped with sample code showing how you can integrate your API key and start working with it straight away. You can view how often your API key is being used and track associated costs. When using API keys for production apps, you are charged on a consumption basis, a popular method of pricing in the developer industry. Let's take a look now at the other method. That's using OAuth 2 and ArcGIS name users to access ArcGIS content and services. This is where you want your application to use ArcGIS identities so that your users can use their own GIS data or their organization's GIS data, as well as content and services that have been shared with them. It relies on an ArcGIS portal, such as ArcGIS Enterprise Portal or ArcGIS Online, providing an access token to your application. But regardless of what method you'll choose, there is plenty of help and support and examples on the ArcGIS developers website, so you can get started with your chosen development framework straight away. We're now going to take a closer look at the ArcGIS Maps SDK for JavaScript. Here we have a sample taken from the ArcGIS Maps SDK for JavaScript website on the ArcGIS developers dashboard, and we can see some sample code. And we can see just how easy it is we can get started and showing a base map in an application. To do this, we need to do just 4 things. Firstly, reference the ArcGIS Maps SDK for JavaScript. We then need to load the specific modules we want, so in this case, the map and the map view. We need to create the map and a 2D view object. And then we're going to bind it to the HTML content so we can show it on our HTML web page. To look at some of the more advanced capabilities of the JavaScript SDK, I'm going to hand over to David.
Thank you, Nick. Now, the first part to building your application is to have some data or have a map or a scene in mind. I always encourage people to start with a sample documentation. I think it's really important to just have a think about what sort of visualization you may want to do, as well as what sort of capabilities you want from your app, particularly if you want to do some analysis against your data. Now, you could have some data that you own, or you might have a particular favorite data set from the Living Atlas. In both cases, brilliant. We can start building our application against this. Now, here on my screen, we have our documentation here. And you'll see up on the top right here, we have the sample code. We can go into this, and we'll get a wide range of samples. And most of these will cover the capabilities we want. I want to stress, you don't need a PhD in computer science to start coding JavaScript. In fact, you don't really need any experience in JavaScript to begin with. We can start using the samples here. And we can start pretend we're in a candy shop, you know, a bit of a pick and mix. We're in a JavaScript candy shop here. On the left-hand side, you'll see we have this intro to scene view. So we've got a 3D scene, and we want to make a 3D application. This is an excellent starting point. If we load this up here, we'll see that we get a nice live sample of an application we can make. And we get the option to explore it in a sandbox. As Nick's mentioned, we can make edits to this in real time and refresh it. So this is an excellent starting point. We can pull this out, and we can load our scene into this. Now, we've already gone ahead, and we've loaded this into Visual Studio with this code. In Visual Studio, it's maybe a wee bit different, but bear with me. We have our index HTML file here. So this is just all the HTML code. This is where we're doing our module loading. It's where we're referring to the JavaScript API itself. So if we just scroll down here, you'll see that right there. We also have this line referring to a JavaScript file. And this is where we're going to keep the code for the capabilities in our application, the widgets. Finally, we have the HTML code at the bottom, which just defines how the application is going to look on the web page. We're keeping it nice and simple. We just want the app to take up the full page. Going over to our application as it currently stands, hopefully this looks familiar. It's just actually outside the QE2. We're using a Blue Sky Metro Vista data, so this is a really nice 3D data set, and it's really detailed. If we zoom in right here, you can read the text on the building even. Blue Sky is actually just outside if you want to talk 3D with them. Now in our application, it's quite bare bones. We've just got a few controls for the camera. In dark mode, of course, we're developers. We love dark mode. But we want to do some analysis against this. We want to maybe record the elevation profile of this building. We also want to add a bit of weather. You know, we're in the UK. This is a UK application. We want to add some rain to it. Going back to the sample code here, we can look up the capabilities we want. So let's start with weather. We can type in weather, and already we've got a nice result here. We can click on this, and like the intro to scene view, we'll get a live demonstration. We'll see what the widget looks like. You can see there's a wee bit extra here with flooding. We can explore it in a sandbox environment. We can see the code that's being used for it. And just like in the candy shop, we can just say, I want that, let's copy it. Now, we've already got some of this code in our Visual Studio, so we'll just go back to that. Go back to our JavaScript file here, and we've just got this commented out. If we just scroll down to the bottom, you'll see that we have the code here for the weather from line 260 to 276. So we're just going to uncomment that. Next, we want to do the same with the elevation profile widget. It's the exact same process. We can just look up the capability, see that there's another sample here. We get a live demonstration. We see how the widget will look. If you don't like it, you can use a bit of JavaScript know-how to change the appearance. But in this, we quite like this, so we're going to just add it to our application. And again, we'll go back to Visual Studio, and we'll comment the lines of code. So here we can see from line 234 to 247, we have the code for the widget itself. And then we just have this extra line, which is going to add it to the user interface. We'll just go ahead and save that, and then we'll give our application a moment to load. And here already, you can see we have the additional widgets added to our app. Easy, hopefully. So we can go and we can start adding more clouds, or we can add some rain. We can also do some shadow analysis, so we can just simulate shadows at various points of the day. And on a data set like this, it looks really nice. Finally, we can do our elevation profile. So if we just go to the widget down here, you'll see that we have a ground and a view. The ground's just going to measure the flat, so the elevation of the ground itself. The view is going to do the elevation of the building. Nice thing with the JavaScript API is we can really change how we visualize data as well as the widgets, the sort of usability of it. And users can quite easily go into this, draw a transect, and they'll get the elevation profile. We'll select done that, and if we just zoom in, maybe we have some work being done on the building, and we don't want people working over heights of 30 meters. We can go along this transect here, and we can start visualizing this on a profile. Just give us a second to load. So there you can see we have the graph visualized over the building, and if we just mouse over the graph, we can, well, ideally see the actual points. There you see, you have it there. Now we're going to go and change the scene up a bit. We're going to use some building information management data. So this is going to be really detailed data on a proposed building development. And we want users to do some analysis of measurements against the building. We also want to enhance some of the usability. So we want users to be able to take a cross-section of the building so they can interact with features on the inside. To start, we're just going to go to our actual scene here, and we've just got on another bookmark. So we'll just save that so it's easy for our application to access. Next, we'll go back to our application, and we'll just remove these lines of code that we just used. Next, it's the same process. We can just go back to our sample documentation, and we can start searching up additional functionality such as slice, which we'll see here. We have a sample for a building scene layer with a slice widget, and we can do the same with measurement. Now, I won't take you through that whole process again, but we can go back to our application, and we can just uncomment these lines of code we've added. So you can see here for the slice widget, it's about 7 lines of code. It's not too complicated. Again, for the measurement widget, we can uncomment this, and then we can add it to the UI. Finally, we're going to add a Flora controller because bin data has quite a lot of features, so we want to make sure we have them all visualized. By default, it only shows the exterior. This widget will allow the whole data set to load. So we'll just go ahead and save that, and then we'll go back to our application. There's quite a lot of features in this, so we'll just give it a quick moment to load. But here we can see we've got our new widgets changed, and I hope that highlights how easy it is to switch out different functionalities in your JavaScript app. You don't have to spend hours and hours tinkering with code to do this. Users can quite simply go draw a slice and then interact with this building, so we can cut a cross-section off it. We could zoom in and decide, oh, we want to do a measurement of this table here. And there we can see it's about 1.53 meters. Again, with JavaScript, maybe not everyone wants to use metric. We can change the default, if we so wish, to a different unit. In terms of deploying an application, again, it's nice and simple. We have an Azure app service here, and much like deploying a website, we can just drag and drop our JavaScript and our index.html to this file, the folder, sorry. So those are uploaded. And here we have a URL for a website. We'll just refresh that. And we should get our website appearing with our new application. Of course, we've got to authenticate first. I'm now going to hand you back to Nick to discuss native applications.
Thanks, David. So far, we've been looking at web applications using the JavaScript SDK. These are web apps that run in a user's browser, either on a mobile device or on a user's desktop. But what about when you need to create applications that run on the device itself? There are a range of native app options and SDKs available from Esri. You can create applications to connect to the ArcGIS system, such as ArcGIS Online, or they can be completely disconnected from a network and the internet with locally run maps and data. Native apps give you the ability to develop cross-platform, such as for desktop and for mobile, being able to leverage the capabilities of the target device. These include the camera, GPS, Bluetooth, and high-accuracy GNSS receivers, to name just a few. One of the most popular frameworks for native applications is .NET, and the ArcGIS Runtime SDK for .NET has recently had some changes. With the latest release of the Runtime SDK, 100.x, this was renamed the ArcGIS Maps SDK for native apps. It still builds on the proven architecture of 100x, as well as leveraging the latest developer framework innovations, including support for MARI, Microsoft's cross-platform framework for creating native, mobile, and desktop applications. Using .NET MARI, you can create multi-platform apps in a single project, and you can also add platform-specific source code and resources if required. One of the key aims of .NET MARI is to enable you to implement as much of your application as possible using a single project and single set of code, including your logic and user interface. And when combined with the ArcGIS Maps SDK for native apps, you can bring the capabilities of ArcGIS into your MARI apps, meaning that you're able to reach a much greater target audience of users and devices. But regardless of the development framework that you choose, the ArcGIS Developer SDKs will allow you to take advantage of the latest features and frameworks, giving a world-class developer experience, including guides and tutorials, an active developer community, and plenty of sample code on GitHub to get you going. Thank you very much. Both David and I will be around after this talk should you have any specific developer questions. Thank you.